So now we're going to be looking at angles of any magnitude. So what I mean by this is, up until now, you've been working with angles of 0 to 90 degrees, right?
Yeah.
But what if we want to work with angles bigger than that, say 180 degrees or 200 degrees or maybe even 325 degrees? Well, we're going to go over how to use those now in our sine, cos, and tan stuff.
Okay.
So, because that'll be necessary when we're moving on to non-right angle triangles, because then we might get obtuse angles, which might be, 170 degrees. So, we're going to start off by looking at what sine, cos, and tan actually is to begin with. And to do that, we need this circle. And don't worry, it'll make sense why we're using a circle in a minute. But this circle has radius 1. So that's 1 unit, that's 1 unit, that goes out to -1, and that goes out to -1, right?
Yep.
So if I start here, and let's say that's a right angle triangle, and it crosses at some point. And I call this angle here, I call it theta. So if this radius is 1, because my radius is 1, so that length is going to be 1, right?
Mm-hmm.
I want to find this side and this side. So how do I do that? Let's try and use Sohcahtoa. So here I want to use my opposite, right?
Yeah.
And my
And
hypotenuse.
so that would be 10.
Oh, I want to find this one first. So I use opposite and hypotenuse because I know my hypotenuse.
So that would be sine.
Yeah, so sine theta equals to opposite over hypotenuse. And what is my hypotenuse?
Your hypotenuse is R.
Yeah, and for this circle, what's my R?
Your R is your radius.
And in this circle it is 1, because it's coming out 1 in all my directions, and I've labeled that side 1, right?
Oh.
Does that make sense?
Yep.
Yeah, so this is called a unit circle. And what that means is it comes out, it has a radius of 1 unit and it starts at the origin. That's what makes it a unit circle, because it's a unit in radius.
Yeah. Okay.
So that gives us that our opposite is equal to our sine theta, right? Because if our hypotenuse is 1, then opposite equals to sine theta. That make sense?
Yeah.
Yeah, so my sine theta is actually going to be my opposite. And what about my adjacent? Well, if I use my adjacent and my hypotenuse, then I get cos theta is equal to opposite over hypotenuse. And what's my hypotenuse? Sorry, that should be adjacent.
Your hypotenuse is 1.
Yep, so my adjacent equals?
Adjacent is equal to, is it shift cos?
Not shift. So my adjacent's over here. And if my hypotenuse becomes 1, I don't worry about what's on the bottom. So I just get my adjacent equals to cos theta, right?
Yeah. Okay.
Because adjacent over 1 is just going to be adjacent. So I get my y value is equal to sine theta, and my x value is equal to cos theta, right? Yep. So from here, do you know a way of writing writing tan theta in terms of sine and cos theta?
In terms of sine and cos theta,
Well, what's tan theta?
like,
It's opposite over
Can be the
adjacent.
opposite over adjacent.
So in this case, it's going to be opposite over adjacent. So it's going to be sine theta over cos theta, right?
Yeah.
Does that make sense?
Yeah.
Yeah. So now, so my sine theta and my cos theta, so if I were to have a point x comma y, so my x is equal to cos theta and my y equals to sine theta, right? Because my x is how far it goes across
Yeah.
and my sine is how far it goes up. Does that make sense?
Yeah.
Yeah. So when I'm between 0 and 90, so let's say this is 0 degrees, so a theta of 0 if it's on this line, and then this theta goes up, 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 all the way to 90. If I'm between this range, what is my sine theta going to be, positive or negative?
It's going to be positive.
Yeah. So sine theta is going to be positive, right? And what about cos theta? Positive or
Would that
negative?
also be positive?
Yep. And if sine and cos are both positive, what does that mean for tan?
It's positive.
Perfect. So sine, cos, and tan theta are all going to be positive in this if I'm between 0 and 90 degrees, right? What if I draw a new triangle over here? So that's my sine theta.
Then
Yep.
they'll convert to negative.
Not will so if I go from 90 to 180 degrees, so my cos, will that be positive or negative?
It'll be negative.
Yeah, it will. Because it's over, so if this is my x-axis and this is my y-axis, over here is positive, over here is negative, right?
Yeah.
But what about my sine? Is my sine positive or negative?
It's positive.
It's still positive, right?
Yeah.
But what about tan? If my sine is positive but my cos is negative, my tan's going to be?
Would that also be positive?
Would it be positive? So over here, I've got
Oh, no. No, it'd be negative.
yeah, because it's a positive divided by negative, which gives me
Yeah.
a negative. Awesome. So from here, I'm going to go from 180 to 270 degrees, and I'm going to draw a new triangle. So here, is my sine positive or negative?
It's negative.
Negative. And my cos, is that positive or negative?
Negative.
And my tan, is that positive or negative?
Negative.
Is it? It's a negative divided by a negative. So what does that give me?
Positive.
Positive, because if I have two negatives, I'm going to get a positive, right?
Yeah.
So from that, here, last bit, if I'm going from 270 degrees to 360 degrees, so if I'm down here, and I draw a new triangle, that's going to be 90 degrees. So that's sine theta, and that's going to be theta in there. So from here, is my sine positive or negative?
Negative.
And my cos, is that positive or negative?
Negative.
Is it?
Yeah.
I'm over here. My cos is my x-axis. Is my x, am I in my positive or negative x direction if I'm going this way from the center?
Oh. So yeah, that'd be positive.
Yeah, positive, right?
Yeah.
So cos is still going to be positive. And what about tan? What does that mean for tan?
It'll also be positive.
Will it? So tan is sine theta divided by cos theta. So that divided by that. So it's going to be a negative divided by a positive. And what does that give you?
So negative.
Negative, right?
Yeah.
So this is called my first quadrant because it goes from 0 degrees to 90 degrees. And then from 90 to 180, it's my second quadrant. And from 180 to 270, this is my third quadrant. And from 270 to 360 degrees, that's my fourth quadrant, right?
Yeah.
Yeah. So there's a little thing you can use to remember which ones are positive and which ones are negative in each of the quadrants. So if I write an A here, an S here, a T here, and a C here. So in this quadrant, all of them are positive, right?
Yeah.
In this quadrant, only my sign is positive, so I write an S.
Yeah.
And in this quadrant, only my tan is positive, so I write a T.
Mm-hmm.
And in this one, it's only cos, so I write a C. And the way you remember this is you go all stations to central.
All stations to central.
Yeah. So you go all the way around, and then it's A for all, S for sine, T for tan, C for cos. Does that make sense?
Yeah.
It's all
Yeah.
stations to central. Now, can I get you to just draw this diagram first?
Yeah. Yeah.
All right. So, have you got all of that down?
Yeah.
Okay. So we're going to move on to a different part of this. So I might choose a different color here. So from here, an important part of this triangle is, so in this quadrant, my sign's going to be positive, right?
Yeah.
And in the second quadrant, my sign's also positive.
Mm-hmm.
But if I'm going, but importantly, if I'm using the same theta here and the same theta here, my sines are also going to be the same value because it's going to reach up to the same height before it touches the circle.
Yeah.
So that's where we're going to be using this, because if I have this theta here, I'll just erase all of this. Make some room. Because if I have this theta here and this theta here, then here I'm going to have sine, let's say I have sine 30 degrees. So that there is 30 degrees, right?
Yeah.
But in this quadrant, I'm not going to be measuring here. I'm going to be measuring all the way from here, right? And how big
Yeah.
is that angle going to be if these thetas are the same?
Would
How
it
big?
be 90? Oh, no. Would it be 150?
Yeah, 150, because I'm 30 away from 180, right?
Yeah.
So I'm going to, over here, I'm going to have sine 150. But now I can say that sine, I'll just actually rub this tan bit off too. Now I can say that sine 30 degrees is equal to sine 150 degrees. That's very bad degrees. Does that make sense?
Yeah.
Yeah. And so that's where we're using this unit circle to come from. We're going to be using it to relate different angles of very large sizes, of varying sizes. Is that okay?
Yeah.
So here,
Yeah.
if I have an angle theta, actually I'll use a different color for this. Let's try yellow. If I have an angle theta, over here, my new angle is going to be 180 minus theta, which is exactly what you did to find 150, right?
Yeah.
But now, what if I kept going and I measured it all the way down to here? What would be my angle in the third quadrant?
Then it'd be 210
It'd be 210, and how did you get there? So
because they all share the same theta.
exactly. So it's 210 degrees. So the formula is going to be 180 plus theta, because I'm going theta past 180, not stopping theta before 180.
Yeah.
And what if I kept going all the way around to here? What would be my theta here?
It would be 330.
330. And how'd you do it? You did
Well, you're 30 degrees away from 360,
perfect.
and they all share the same theta.
Perfect. So you did 360 minus theta, right?
Yeah.
So in the first quadrant, it's theta. In the second, it's 180 minus theta. And in the third, it's 180 plus theta. And finally, in the fourth, it's 360 minus theta. So from here, so sine 30 is equal to sine 150. But does sine 30 equal to sine 210?
Yeah.
Not quite. They're the same size, but what can you tell me about sine 210? Is it going to be positive or negative?
It's going to be negative.
It's going to be negative. So sine 30 is positive, but sine 210 is negative. So hypothetically, let's say that that equal to 1, right? So that would
Yeah.
also equal to 1, right?
Yeah.
And what would this equal to?
that would be equal to -1,
Perfect. And what about this one?
-2.
Not -2, because it's still the same theta. So the sign magnitude doesn't change. It's going to be -1.
Oh, true. Yeah.
Yeah.
Okay.
So because sine is positive in the first two quadrants, the value is going to be positive. But in the third and fourth, it's the same magnitude. So there's the same size, but third and fourth, they're going to be negative, right?
Yeah.
Yeah. And so that's the sort of thing that we can use this for, using these sorts of equations.